Now we will start this video with question 21. In the question 21, the sets eta, x, and y satisfy the conditions. The number of elements in the universal set is equals to 11. The number of elements in the set x is equals to 4. And the number of elements in the set y is equals to 7. We have to find out the smallest possible value of n of x intersection y whole complement. Since in the part 1, n of x intersection y whole complement is smallest when n of x intersection y is largest. This will occur when x is a subset of y. So the smallest possible value of n of x intersection y whole complement will be, we can find out the smallest possible value of n of x intersection y whole complement by subtracting the number of elements of the set y from the set eta. So the respective values are 11 minus 7. And after subtracting, we will get 4. So the smallest possible value of n of x intersection y whole complement is equals to 4. Now in the part 2, n of x intersection y whole complement is largest when n of x intersection y is the smallest. This will occur when x intersection y is equals to 5. It means x and y are disjoint sets. There is nothing in common between the sets x and y. So the smallest, so the largest possible value of x intersection y whole complement will be equals to 11 minus 0. We have 0 here just because number of elements in the set x intersection y is equals to number of elements in the set y, and that is equals to 0. So we have to just write it down like 11 minus 0, and the answer is 11. So the largest possible value of n of x intersection y whole complement is equals to 11. Now in the question 22, illustrate on a Venn diagram that sets P, Q, and R. If Q is a subset of P and R is a subset of Q complement, and P intersection R is non-empty. In the question, we have to draw the Venn diagram. So here we will draw a rectangle representing the universal set eta. Inside it, we will have 3 sets representation, P, Q, and R. But we will follow the conditions that are given in the question, and we will draw the Venn diagram. So here we have 2 overlapping circles, P and R. Now, what about set Q? The set Q is a subset of set P. So there is another condition on the set Q. R is a subset of Q complement. So it means the circle of the set Q will only be lies inside the set P's circle. So the circle inside the set P's circle represents the set Q. So this is the illustration of the Venn diagram the conditions given in the question. Now, in the question 23, the universal set eta is the set of all the triangles, given that S is equals to X such that X is an isosceles triangle, T is equals to X such that X is an equilateral triangle, and X such that X is an obtuse angled triangle. So we have to draw a Venn diagram to represent the sets eta, S, T, and U. So first we will see what is isosceles triangle. Isosceles triangle is a triangle having two sides of equal length. Now, what is equilateral triangle? Equilateral triangle having all the sides of equal length. And the obtuse angle triangle is a triangle having a one angle that is obtuse and the other two angles are acute angles. Or in other words, the triangle having one angle greater than 90 and two angles less than 90 is known as obtuse angled triangle. So it is given in the question that we have a universal set eta. So for universal set eta, we will draw a rectangle to represent the universal set eta. Inside it, we will draw circles, two overlapping circles. Now these two overlapping circles represent which sets? It will represent the set S and U. Just because the sum of all the interior angles in both type of triangles is 180 degrees. Now, what about this triangle, equilateral triangle, the set T? The set T will be the subset of the set S, just because equilateral triangle is a subset of the isosceles triangle. So the set T will be lies inside the set S. So this is the illustration on Venn diagram of the sets eta, S, T, and U. Now here we have the question 24. For any set A, simplify the following if possible. So here we have to take a specific example to understand these set operations. So for this, suppose eta is equals to 1, 2, 3, and 4. And the set A is a proper subset of set eta, so it will be equals to 1 and 3. Now, we want to find out A intersection universal set eta. So here the set A is 1 and 3. Intersection and the set eta is 1, 2, 3, and 4. So the common elements in both the sets is 1 and 3. So the answer of A intersection eta is equals to 1 and 3, and that is equals to the set A. So A intersection eta will be equals to the set A. Now for part 2, we have to find out A union eta. The set A is 1 and 3 union, and the set eta is 1, 2, 3, and 4. So we just have to put all the elements in both the sets together. So here we have 1, 2, 3, and 4, and that is equals to eta. So A union eta will be equals to eta. Now in the part 3, we have A intersection phi empty set. So here the set A is 1 and 3 intersection, and the set phi is empty set. So here we have nothing in the set phi. So the answer will be the set phi So A intersection phi is equals to empty set, and that is equals to phi. So A intersection phi is equals to phi. Now in the part 4, we have to find out A union empty set. Since the set A is 1 and 3, union the set phi is the empty set. So we have to just put all the elements in both the sets together. So here we have 1 and 3 in the union, and that is equals to set A. So A union phi is equals to A. Now in the question 25, if A is a subset of B and A intersection C is equals to phi, it means A and C are disjoint sets. To simplify the following, if possible. So for this, we will draw a Venn diagram according to the conditions that are given in the question. So for this, here we have a rectangle representing universal set eta. Inside it, we will draw two circles. Bigger circle represents the set B and the smaller circle represents the set A. Since A is a subset of B, now we will draw another circle, but that circle will be disjoint, and that represents the set C. Now we will solve the part 1 with the help of Venn diagram. So here we want to find out A intersection B. So the region in the set B and the set A that is common to both the sets is the region of the set A only. So A intersection B is equals to A. Now in the part 2, we have to find out A union B. So A union B means the region of the set A and B both will be included in the shaded region. So A union B is equals to B. In the part 3, we have to find out B intersection C. Since from the Venn diagram, we can see that B and C have no connection between them. So it is not possible to simplify the B intersection C further. Now in the part 4, we have to find out A union C. If we shade the region for the set A union C with blue, according to shaded region, it is not possible for us to simplify A union C further. Just because A union C does not equals to any set A, B, or C. And A and C are disjoint sets, so their union cannot be simplified further. Now in the part 5, we have to find out B union C intersection A. So for this, we will use the Venn diagram. So here we have a rectangle representing the universal set eta. Inside it, we have circles representing the sets A, B, and C respectively. Since first we have to find out B union C, so we will shade the region for B union C. Now, in the second Venn diagram, we will draw another rectangle representing the universal set eta. Inside it, we will draw circles representing the sets A, B, and C respectively. Now we will color or shade the region for the set A only with the red color. Now in the third Venn diagram, we will draw another rectangle representing the universal set eta. Inside it, we will draw circles representing the sets A, B, and C respectively. And now in the third Venn diagram, we will use the blue color. Now in the last Venn diagram, we will use the green color to shade the region to represent the set B union C intersection A. So in both the Venn diagrams, we just have to shade the region that is common in the first and second Venn diagram, and that is the region for the set A only. So by using the Venn diagram, the last or the third Venn diagram, we will get B union C intersection A is equals to A. Now in the part 6, we have B intersection C intersection A. So here we will draw a rectangle representing the universal set eta. Inside it, we will draw overlapping circles representing the sets A, B, and C respectively. Now we will use the red color to shade the region for B intersection C. Since there is nothing in common between the sets B and C, so we will not shade any region. Now we will draw another Venn diagram. And we will draw three circles here representing the sets A, B, and C. Now we will use a blue color to shade the region for the set A. In the part 6, we have to find out B intersection C intersection A. Since A, B, and C are the disjoint sets, so B intersection C intersection A will be equals to phi. Now in the part 7, we have to find out A union C intersection B. For this, we will draw a rectangle representing the universal set eta. Inside it, we will draw 3 circles. Representing the sets A, B, and C. Now we will use the red color to shade the region for the sets A union C. Red color representing the set A union C. Now in the second Venn diagram, we will draw another rectangle representing the universal set eta. Inside it, we will draw 3 circles representing the sets A, B, and C. Now we will use the blue color to shade the region for the set B. Since we have to find out A union C intersection B, but there is nothing in common between the first Venn diagram and second Venn diagram's shaded region, so we cannot simplify it further. It is not possible to simplify it further. A intersection C union B. So for this, we will draw a rectangle representing the universal set eta. Inside it, we will draw circles representing the sets A, B, and C respectively. Since A intersection C is equals to phi, so there is no overlapping region between the sets A and C. Now we will draw another rectangle representing the universal set eta. Inside it, we will draw circles representing the sets A, B, and C respectively. Now we will shade the region for the set B with red color. Now we will draw another rectangle representing the universal set eta. Inside it, we will draw 3 circles representing the sets A, B, and C respectively. Now we will use the green color to shade the region for A intersection C union B. So in the third Venn diagram, we just have to put all the shaded region together. So the shaded region in the third Venn diagram, shaded with the green color, representing the set B. So A intersection C union B will be equals to B. In question 26, describe the shaded region in the Venn diagram in set notation. So according to the given diagram, it represents P intersection Q, all complement union P complement intersection Q. And by using the answer to part 1, the shaded region in the Venn diagram in set notation for part 2 is P intersection Q, all complement union P complement intersection Q union P union Q, all complement. The question 27 says, in a class of 35 students, 11 students like noodles, 21 students like rice, and 7 like neither. Find the number of students who like both noodles and rice. So let N and R be the set of students who like noodles and rice respectively. And let X be the number of students who like both noodles and rice. So X will be filled in the overlapping region, and the number of students like noodles. So we will have 11 minus X who only like noodles, and 21 students like rice. So 21 minus X are the students who like only rice, and the 7 students who like neither. So we will put the 7 in the rectangle of set eta. Since we have filled in all the information in the Venn diagram, now we will use the information fill in the Venn diagram to find out the number of students who like both noodles and rice. So here we will add up all the information. 11 minus X is the number of students who like only noodles, plus number of students who like only rice is equals to 21 minus X, plus 7. The number of students who like neither noodles nor rice is equals to 35, the total number of students. Also, the number of students who like both equals to total number of students, which is 35. Now we will simplify this. 11 minus X plus 21 minus X plus 7 plus X equals to 35. Now this X goes, minus X goes with cancel with plus X. 11 plus 21 plus 7 goes to 39. So 39 minus X is equals to 35. Now we have minus X is equals to 35. When this plus 39 goes on the right hand side, it will become minus 39, and it will gives us minus 4. Now the minus sign on both sides will be cancelled out, and we will get X is equals to 4. So the number of students who like both noodles and rice is equals to 4. Now the statement of the question 28 is, 40 working adults were asked to complete a survey about their modes of transport to work. 12 of them commute to work by bus, 25 of them commute to work by train, and 8 of them do not commute to work by bus or by train. Find the number of working adults who commute to work either by bus or by train, but not both. Now let X be the number of adults who commute to work by both bus and train. So number of adults who commute to work only by bus will be equals to 12 minus X. The number of adults who commute to work only by train will be 25 minus X. And the total number of adults who surveyed is equals to 40. And the number of students who commute neither by bus nor by train is equals to 8. So now if we put all these values together and put them equals to 40. So 12 minus X plus 8 plus 25 minus X plus X goes to 40. Now we are getting simplified. 12 minus X plus 8 plus 25 minus X plus X equals to 40. This plus X will be cancelled out with minus X, and then we have got 45 minus X equals to 40. And this plus 45 goes on right hand side, then it will become minus 45. So minus X equals to minus 5, and this minus sign on both sides will be cancelled out. So X is equals to 5. So the number of adults who commute to work by both bus and train is equals to 5. Now number of adults who commute to work by only bus will be equals to 12 minus 5, and this will be equals to 7. And the number of adults who commute to work only by train will be equals to 25 minus 5, and it will gives us 20. So now we will add up 7 plus 20. We have got 27. So the number of adults who commute to work either by bus or by train but not both equals to 27.
Question 29 statement says, a group of 90 people is surveyed on their hobbies, and the results are shown below. Dancing 43, sewing 42, swimming 48, dancing and sewing 16, sewing and swimming 17, and swimming and dancing 22. Each youth has at least one hobby. It is given that a youth have 3 hobbies. So draw a Venn diagram to represent the above information, including the number in each separate region in terms of X where necessary. So let D, S, and W be the sets of people whose hobbies are dancing, sewing, and swimming respectively. Now, the number of people whose hobby are dancing and sewing but not swimming. So that is equals to 16 minus X. And now the number of people whose hobbies are sewing and swimming but not dancing is equals to 17 minus X. And the number of people swimming and dancing but not sewing is equals to 22 22 minus x. And now here let x be the numbers of people who have all the three hobbies: dancing, sewing, and swimming. Now we will make further calculations to represent on the Venn diagram for the part 1. So the number of people whose hobby is dancing but not swimming and sewing, so it will be equals to 43 minus 16 minus x minus 22 minus x, and after simplifying it we will get 5 plus x. Now the number of people whose hobby is sewing but not dancing and swimming, it will be equals to 42, just because it is given in the question the people who have the hobby of sewing is 42. So 42 take away 16 minus x, take away minus x, take away 17 minus x, and after simplifying we will get 9 plus x. Now the number of people who likes swimming but not dancing and not sewing, so the number of people who like swimming only is 48. So 48 take away 22 minus x, take away x, take away 17 minus x, and it will gives us, after simplifying, 9 plus x. Now we have drawn a Venn diagram to represent the above information given in the question and fill in the regions with the required information. So this region shows only D, this region shows only S, this region shows only W, this region shows D intersection W intersection S. Now in the part 2, write down an equation x and show that it simplifies to x plus 78. Now we will put all the fill-in information of the Venn diagram together and put it equals to 90. Since we have 90 people, so 5 plus x plus 5 plus x plus 16 minus x plus 9x plus x plus 22 minus x plus 9x plus 17 minus x equals to 90. So after simplifying, we will get the required equation as shown. X plus 78 is equals to 90. Now in the third part, we have to solve the equation x plus 78 is equals to 90, and after simplifying it we will get x is equals to 12.
In question 30, medical test, 68 elderly men diagnosed with at least one of the following diseases: heart disease, lung disease, and kidney disease. The information below shows the numbers of men with the diseases: heart disease 30, lung disease 30, kidney disease 33, heart and lung diseases 7, lung and kidney diseases 10, heart and kidney diseases 11. Let x be the number of men diagnosed with all three diseases. Part 1, we have to draw a Venn diagram to represent the above information, including the number in each separate region in terms of x where necessary. So let H, K, and L be the sets of people who diagnosed with heart disease, kidney disease, and lung disease respectively, and let x be the number of people who diagnosed with all the three diseases. For this, we have n of H intersection K intersection L complement. So H intersection K intersection L complement, we have 11, the people having heart and kidney diseases but not having lung disease. So we will have number of people having heart and kidney disease but not lung disease equals to 11 take away x. Similarly, for the people who have lung disease and kidney disease but not heart disease is equals to 10 take away minus x. In simple words, we have subtracting the number of people who diagnosed with all the three diseases from the people who have heart and kidney disease at a time, who have lung and kidney disease at a time. And in last but not the least, the number of people who have heart disease and lung disease but not kidney disease is equals to 7 take away minus x. Now we will find out the number of people who have heart disease but not the kidney and lung disease. For this, given in the question, the people having heart disease is equals to 30, and we will take away 11 minus x, which is the number of people having heart and kidney diseases, minus x is the number of people who have all the three diseases, minus 7 minus x is the number of people who has heart and lung diseases at a time. So after simplifying it, we will get 12 plus x. Now we have to find out the number of people who have kidney disease but not the heart or lung disease. For this, we will have equals to 33 minus take away 11 minus x minus 10 minus x. And after simplifying it, we will get 12 plus x. So this is the number of people who are having kidney disease but not the heart and lung disease at a time. And the last but not the least, the number of people who have lung disease but not the heart and kidney disease. So they are given in the question. The people having lung disease equals to 30, and we will take away 7 minus x and minus 10 minus x from 30, and after simplifying it, we will get 13 plus x. Now we have drawn a Venn diagram to represent the above information and indicating the number in each separate region in terms of X. So we have three sets H, K, and L, and this region is only H, people having heart disease only. This region shows only K. This region shows only L. This region shows H intersection K intersection L. This region is H intersection K. This region is H intersection L, and this region is K intersection L. So this is the Venn diagram that represents the above information in terms of X. Now for part 2, since we have 68 men, so we will add up all the information that we have shown in the Venn diagram and put it equals to 68, and after simplifying it we will get a equation x plus 65 is equals to 68. This 65 when goes on the right hand side, it will become minus 65. So 68 minus 65 gives us x is equals to 3. Now in part 3, hence how many men were diagnosed with only lung disease. So the number of men who diagnosed with only lung disease is equals to 13 plus x. So we have find out the value of x in part 2. Value of x was 3. So 13 plus 3 is equals to 16. So hence the number of men who diagnosed with only lung disease equals to 16. Now in question 31 we have, in a certain school students must study at least one of the following subjects: mathematics, science, or geography. Among a group of 40 students, the number of students who study the subjects are given below. Mathematics 20, science 22, geography 28. Mathematics and science 12, science and geography 14, mathematics and geography 15. How many students study all three subjects? Let G, M, and S be the number of students who study geography, mathematics, and science respectively. Let X be the number of students who study all the three subjects. Now we have the number of students who study mathematics and geography but not science. They are equals to 15 minus X. The number of students who study science and geography but not mathematics is equals to 14 minus X. The number of students who study mathematics and science but not geography is equals to 12. Now we will find out the number of students who study geography but not mathematics and science. So it is given in the question, the students who study 28, only geography are 28, and we will take away the number of students 15 minus x minus 14 minus x from the 28, and after simplifying we will get x minus 1. Similarly, we will find out the number of students who study mathematics but not geography and science. They are equal to 20 minus 15 minus x minus 12 minus x, and after simplifying we will get the number of students who study science but not geography and mathematics equals to 22 minus 14 minus x minus 12 minus x, and after simplifying we will get x minus 4. Now we have drawn the Venn diagram, and now we will label the regions. This tells us about only G, the number of students who only study geography. This tells us about only the students who study mathematics. This is only S. This region tells us the students who study all the three subjects: G intersection M intersection S. Since there are 40 students, so we will put together all the information we have write down in the Venn diagram and put it equals to 40, and after adding up we will get x plus 29 equals to 40, and this 29 when goes on other side it will become minus 29. So 40 take away 29 will gives us x is equals to 11. So hence the number of students who study all the three objects is 11.
In a class of 38 students, 15 students enjoy cycling and
9 students enjoy swimming. Find in the part 1 the largest possible number of students who enjoy cycling or swimming. So let C and S be the set of students who enjoy cycling and swimming respectively. For the first part, N of C union S is largest when C intersection S is equals to 5. So for this, it means C and S are disjoint. There is nothing in common between the sets C and S. So the largest possible value of N of C union S will be adding 15 plus 9. It is equals to 24. So the largest possible number of students who enjoy cycling or swimming is 24. In part 2, we have to find out the smallest possible number of students who do not enjoy cycling or swimming. So N of S union C whole complement is smallest when N of C union S is largest. So the smallest possible value of N of C union S will be find out by 38 minus 24, and it will gives us 14. We simply subtract the number of students who enjoy cycling or swimming from the total number of students, and we get 14, the number of students who do not enjoy cycling or swimming. In the part 3, we have to find the largest possible number of students who enjoy cycling and swimming. So N of C intersection S is largest when C is a proper subset of S. So the largest possible value of n of C intersection S will be equals to 9. So the largest possible number of students who enjoy cycling and swimming is equals to 9. Now in part 4, find the smallest possible number of students who enjoy swimming but not cycling. So for this, n of C complement intersection S is smallest when n of C intersection S is largest. So the smallest possible value of n of C complement intersection S will be equals to 9 minus 9, which gives us 0. So there is no students who enjoy swimming but not cycling. Now in question 33, the last question. In a group of 35 children, 13 of them enjoy playing board games and 20 of them enjoy playing card games. Find in the first part the smallest possible value of children who enjoy playing board games and card games. So let C and B be the set of students who like playing card games and board games respectively. So in the part 1, n of B intersection C is smallest when B union C is equals to set eta. So smallest possible value of n of B intersection C is 13 plus 28 take away 35, the total number of children, and it will give us 6. So the children who enjoy playing board games and card games are equals to 6. Now in part 2, find the smallest possible number of children who do not enjoy playing board games or card games. So n of B union C whole complement is smallest when B union C equals to eta. The smallest possible value of n of B union C whole complement will be 35 minus 35, and it will give us 0. So there is no children who do not enjoy playing board games or card games. Now in part 3, find the smallest possible number of students or children who enjoy playing board games or card games. So n of B union C is smallest when B is a proper subset of C. So the smallest possible value of n of B union C will be equals to 28. So the number of children who enjoy playing board games or card games equals to 28. In part 4, find the smallest possible number of children who enjoy playing card games but not board games. For this, B complement intersection C is smallest when n of B intersection C is largest. So the smallest possible value of n of B intersection C can be found out by 28 minus 30. It will give us 15. So the number of children who enjoy playing card games but not board games is 15.